Now the next method is the Multizone method. In order to use and explain this method, we need to make some changes to our geometry. Therefore, we have to exit the ANSYS Meshing software and then start the ANSYS Design Modeler. Now in the Design Modeler software, click on the Extrusion command that we use to create the cylinder bit. The low left side of the software window in front of the operation, change it from slice material to add material, and then under the direction section change it from reverse to normal so that we can have a cylinder outside our box. We should create another box on the surface which is selected here, and as you can see it. Therefore, we select the surface selecting command and then click on the surface which is colored with green. Then click on the sketching button. Simply select the rectangle command and then draw a rectangle over that surface. Next step is to extrude this rectangle, therefore we click on the extrude command. Now our new geometry is completed and we can close the Design Modeler software. Now the multi-zone method is somehow similar to the method which you divide your geometry into different parts so that you can create a structured mesh for it. However, the multi-zone method provides you the capability to create a structured and unstructured mesh for geometry at the same time. For example, you can create a structured mesh over the smaller box and over the cylinder while creating unstructured mesh over the bigger box. For the first step, we leave the settings by default and we just simply click on the mesh and then click on generate so that we can see how the software generates mesh for its geometry. It only should be mentioned that there's a high chance the software cannot generate structured mesh for our geometry because of its complexity. Now, as was mentioned before, you can see that the software wasn't able to create mesh for our geometry. However, you can see that the software even tried to create a structured mesh over this geometry, but it failed. In order to have a better view of the generated mesh, we are going to first rotate our geometry and then using the section plane command, view its interior mesh. As was mentioned before, we select the section plane command and then draw a line from the top side of the geometry to its bottom. As you can see in this slide, the software has tried to fill the two boxes, the smaller one and the bigger one, with a structured mesh. However, it couldn't connect the interior nodes of these two boxes with each other. Therefore, it failed to create the structured mesh. Here, you may think that the multi-zone method does not have the capability to generate mesh over complex geometries. However, it should be mentioned that the settings that we used to create mesh for this method was the software's default. You can simply change some settings and then generate some high quality mesh cells, even for the most complex geometries. Now, prior to explaining each setting and option here, we first are going to create an initial mesh for our geometry, and then we will come back and talk about other options. Therefore, to generate the initial mesh, we are going to change the free mesh type section. The free mesh type section represents the mesh cells that are placed in the sections that the software is unable to create a structured mesh for. For example, the bigger box interior. For example, if you change the free mesh type section from not allowed to tetra, we will let the software to fill the bigger box with tetrahedral mesh cells and then create a structured mesh for the smaller box and the cylinder. Now, as you can see here, structured mesh are created inside the smaller box and the cylinder, while tetrahedral mesh cells are placed inside the bigger box. Also, you can see that the interior nodes between the smaller box and the bigger box, also between the cylinder and the bigger box, are completely connected and our generated mesh is correct. Now that our initial mesh is generated, we are going to talk about each option shown here step by step. The first option is the mapped mesh type, which is the type of mesh cells that are placed inside the sections which the software is capable of generating a structured mesh for. For example, if you click on it, you can select between three options of Hexa, Hexaprism, and Prism. The Hexa representing the hexahedral cells and the Prism representing the prism itself. For example, if we select Prism for the mapped mesh type, you will see that in the sections like cylinder and the smaller box where we had hexahedral structured mesh before, the software will put a structured prism cells instead. For example, if I rotate the geometry now, you can see that in the sections like the cylinder and the smaller box where the software was able to put a structured mesh on, instead of the hexahedral cells, the software has put prism cells which have 5 faces instead of 6. Pay attention to the outer surface of the smaller box which has the triangular mesh cells, and in the depth of it where it's like the rectangular cells are placed. Now this type of mesh cell is called prism. Also the same can be said about the cylinder. Now the next option is the surface mesh method. If you click on it, you will see you have two options of uniform and pave. Now the surface mesh method is normally used for the sections where we have an unstructured mesh over. For example, in this geometry, the bigger box. If you click on it and then select uniform, you can see that the shape of the tetrahedral mesh cells over the outer surface of the bigger box will become more uniform comparing to what you can see now. Generally, this option is used to create or generate a higher quality mesh over the sections of your geometry which you couldn't generate a structured mesh for. Using it will put some limitation for the software and makes it hard for the software to mesh your geometry. Therefore, for the non-rectangular shapes which you have curves in them, it is recommended that you use the paved option. Now if you compare the mesh cells generated over the outer surface of the bigger box with the previous mesh, you can see that the mesh cells over the outer surface are more uniform. As we have two options for the surface mesh method, uniform and pave, we can understand that the previous mesh used the pave option. Now here we change the surface mesh method to its default, and then we are going to talk about the free mesh type section. Now if you click on the free mesh type setting, you can see you have options like tetra, tetra or pyramid, hexadominant, hexacore. As you can remember, we selected the tetra option for the previous mesh cells. Now in this slide we are going to select the tetra or pyramid option, and then we will create the new mesh to see the differences and the changes that it will make. Now the first difference that you can see here is the outer surface of the bigger box. By knowing the structure of a prism mesh cell, you can understand that the outer surface of the bigger box is filled with prism mesh cells. Now we are going to rotate our geometry to see its interior. In this slide, you can easily see that the interior section of the bigger box is filled with tetrahedral mesh cells. Now the most important parts are the places where the cylinder and the smaller box are connected to the bigger box. These connection parts are completely filled with prism mesh cells so that they can act as a bridge between the hexahedral mesh cells and the tetrahedrals. Now the next option that we are going to select for the free mesh type is the hex dominant. When we select this option, it will make the software to mainly put the hexahedral mesh cells inside the bigger box. However, there is a great chance that just like the initial mesh that we wanted to create, this new mesh fails too. As was mentioned, you can see here that the software failed to create the mesh in which we wanted to have hex dominant mesh cells inside the bigger box. And you can easily see why. The quality of the mesh cells generated inside the box are relatively low. Here you can easily see that the software was able to create a structured mesh for the smaller box and the cylinder. It also was able to connect the interior nodes between the bigger box and the smaller box, and between the bigger box and the cylinder. However, the hexahedral mesh cells that are placed inside the bigger box have relatively a very low quality that couldn't pass the quality check test of the software. Therefore, they aren't appropriate for any analysis software to perform simulation on. The final option related to the free mesh type setting is the hex core. In this option, the software will try to fill the core of the section where structured mesh cannot be placed with hexahedral cells, and then try to put tetrahedral mesh cells at the border of that section. For example, if I generate the new mesh, you will see that the core of the bigger box will be filled with hexahedral mesh cells, while the outer layer of the bigger box will be filled with tetrahedrals or prism cells. Now here, when the mesh is generated, if I zoom in a little bit, you can see that the inner core of the bigger box is filled with hexahedrals, while the outer layer of the bigger box is filled with tetrahedrals, or in the connection points between this bigger box and the cylinder, or the bigger box and the smaller box, filled with prisms. Also here, I will rotate the geometry so that you can see the outer layer mesh created for this geometry. Now, just like the previous slides, in order to see the effect of other options, we first change the free mesh type to tetrahedrals, and then we are going to talk about the other options. The next option is the element order. As you can probably remember, this option controls the number of nodes that are placed over each element, and that you can select between linear or quadratic. Now the next option is the source or target selection, just like what we had explained about the sweep method. When you set it to manual source, you have to select a face over which you have defined your specific type of mesh, and that you can create some sort of sweep mesh for that part. However, if you let it to be automatic, the software will automatically decide over which parts of your geometry it can generate sweep mesh or structured mesh. Now that I have selected manual source, I can simply select the upper surface of my cylinder, and then software will understand that I want to create structured mesh and sweep mesh over my cylinder. Next option is the sweep size behavior. When you select this option, you are able to control the size of the swept mesh over the parts of your geometry where a structured mesh is generated. For example, over the cylinder or over the smaller box. But before changing any settings for this option, we are going to first see the distance between two adjacent nodes for the swept mesh over the cylinder. Therefore, we select the node selecting command and then click on two adjacent nodes over the cylinder. Here you can see that the distance between these two adjacent nodes is almost equal to 7 cm, which is the element size that we have defined in the global settings section. Now, for example, if we change the value in front of the sweep element size to, for example, 4 cm and then click on generate, you will see that the distance between these two adjacent nodes will reduce to 4 cm. As was mentioned, here you can see that their distance is almost equal to 4 cm. Next, if you click in front of the sweep size behavior along with sweep element size, you will find another option with the name of sweep edges. If you click on this option, the software will ask you for an edge. This edge is the edge where you want to create your sweep mesh along it. For example, let's say you want to create sweep mesh for your smaller box geometry using this method. After creating the specific type of mesh over the cross section of your smaller box, the direction that you want to sweep your mesh is the depth of the smaller box. Therefore, you have to select the edge placed along the depth of your geometry. It also should be pointed out that the edge that you're selecting should have cell divisions on them. Placing cell divisions over an edge will be explained in next sessions. Therefore, we change the sweep size behavior to its default, which was a sweep element size. Also, if you see the last option with the name of write ICEM CFD files, you can export your generated mesh for your geometry as an ICEM file.